In this next lesson, now that we understand domain and range, we're going to continue to investigate relations by determining when is a relation actually a function. So this is a very important thing throughout algebra strand classes, is something a function or not? And what it means to be a function is each element of the domain corresponds with exactly one element of the range, okay? Now, this means two different things, okay? So for mapping, this means that that an element in the domain should not branch off, okay? Because if an element in the domain is branching off, that means it's being used twice, okay? So let me show you what that means. So here, every domain should go to exactly one y value, okay? So here 3 is going only to -2, 0 was going only to 7, and 4 is going only to 1. Okay, so each element of the domain is only going to one location. So this actually fits the rule. This is going to be considered a function. Every element of the domain only goes to a single element in the range. Now I want you to look right below that, okay? This shows that falling apart, okay? Because 6 only goes to 6, which is perfect. 4 only goes to 3. 3 only goes to -1, but notice this 2 right here. That 2 is being split. That 2 is going to multiple locations. It's going to -3 and it's going to 3. So that is where this actually falls apart, okay? A function would have no value in the domain that does that, no value in the domain that can go multiple places. So this is not a function. All right. Now, what about in terms of a list of points? Now here I actually realized that I forgot to type it in, but what you can do is actually write it in for me. So here, when you're dealing with just lists of ordered pairs, okay, you should see X not repeat. Okay, actually maybe I'll say X should not repeat, so it's actually a good phrase. So X should not repeat itself if you're looking at a list of ordered pairs. Because if X repeats, it means that X value is being used for multiple Y values, okay? And again, that would make it fall apart. So let's take a look at this. We have 4, 8, 1, 6. Oh, I see another 4. So this is a problem, okay? It's a problem because it's showing an element in the domain, so an X, that is being used to go to multiple pieces in the range, or the Y's. So this first one is not a function because those X's should not be going to different places. X should only exist once there, be going to one place. Let's look at this one though. So here I have a -7, a 9, a 14, a 7. So this one is okay, okay? Each X is only used once, okay? It's only represented once, going to a single Y value. So this is definitely a function, okay? That fits the rule that we're looking for. Now, one rule that I know most kids enjoy using is the vertical line test. So if we're dealing with something graphically, okay, so you're dealing with the graph, the vertical line test is what you can use to determine if something is a function or not. So when you're looking at the vertical line test, if it touches twice, it means that element in the domain is going to multiple places and that it is not a function. So basically the rule is if I can draw a vertical line anywhere that touches more than once, not a function, it falls apart. The element of the domain is used more than once. If it only touches once, everywhere in the domain, then it is a function. So let's take a look at this. The first couple have some lines already pre-done for us. This vertical line, I notice, touches twice, okay? It it intersects with that graph twice. Remember, that is a huge no-no. That is not going to be a function because that piece of the domain, that x value, is being used to go to two separate y values, okay? Absolutely not a function. The next one. So the next one, it doesn't matter where you draw that line. Every time I draw a vertical line, do you see that it only ever touches once? Okay? There's no way to draw a vertical line where it touches more than once. So this actually passes. This is going to be a function. You can even do the same thing when you just have like points on the graph, okay? As long as you can't draw a vertical line that goes through two of them, you can still determine if it's a function or not. This one, however, this vertical line does actually pass through two of them. So what that would mean is this one is not a function. All right, you can get it to touch in two places. All right, down here. Again, I think this one is hopefully pretty easy for you to see. I can draw a vertical line that touches twice, right? So this one right away, hopefully you can see, falls apart. This one is not a function. This one, if you look, no matter where I draw the vertical lines, it never touches more than once, no matter where I put the vertical line. So that one is actually a function. And same thing here. Doesn't matter where I draw that vertical line, it's ever only touching once. Therefore, this is going to be a function. So really quickly, let's just review the skills we've gone through so far in Chapter 2. So I have one more example for us, and it's actually asking us to determine the domain and range and determine if it is, in fact, a function. So domain. Remember, when you hear domain, you should think x values. So let's investigate what x values are being used here. So here, the function is starting here. And then in terms of x, it's going up to here. Okay, so that green line basically is me just visualizing what x's are overall being used. Okay, so this would be starting at -1 and -4. Those are what are kind of bounding the x values that I'm able to use. Okay, how far and left can I go? So in this one, I'm going to show that that is bounding my x, okay? The only x's I'm using are between -4 and -1. For the range, the y values, how high and low are you going? Well, again, it's starting at this point right here. Then if you look at how high it's going all the way up to the peak of that thing, okay? And so here, when we're talking about y's, I'm seeing it starts down at -2 and it's going up to +2. So those are going to be the bounds of my y's. And then finally, is this thing representing a function or not? So if I draw vertical lines, I can never get it to touch more than once. Every vertical line I put touches exactly once. Therefore, this thing is going to be a function. All right, so once again, thank you so much for joining me. Make sure after you get all these notes down, then you can move on and start working on that worksheet paired with it.